Here we are moving into review lesson 3. So these are mainly true-false questions. So I am going to show you how to use logic to say whether or not these are true or false. Okay, so if two chords of a circle bisect each other, each chord must be a diameter. So I've got a circle, and let's see, I've got a chord here, and I'll make one of the chords a diameter. It's true that when it's a diameter, it bisects that chord. However, you can see that this chord does not bisect my diameter. However, if I draw two diameters and make them meet at a right angle, they do actually bisect each other. So it must be a diameter. This is actually true. Okay, a right triangle is determined when one side and the ratio between any two sides are known. So if I were to sit here and say, I know this side is 4. And I know that the ratio between this side and this side is 2/3. 4/6 then would be this side. And then I could see 4 times 4 is 16, plus 6 times 6 is 36. 16 plus 36 is 52. So that one is not a right triangle. So that is actually, I'm going to say that is false because that is not a guaranteed determinant of telling whether or not it's a right triangle. It can, but that's not the determining factor of a right triangle. I would say the determining factor is more so the whether or not it has a right angle. Okay. If the length of a chord is doubled, the length of its arc is doubled. This is actually true. Because if I sit here and I say, oh, okay, I have this chord right here and it is 2. And then I go over here and I add this other chord, which is also 2. I am actually doubling that because I'm taking this arc length, which is the same as this arc length, and adding them together, which is doubling them. Okay, if the diagonals of a parallelogram are equal, the parallelogram is equiangular. This is actually a true statement. This was back when we were going over all the different shapes and we were talking about quadrilaterals and parallelograms and kites and trapezoids. If you go back over that chart, you will actually see that this is one of the ways to tell whether or not, it was one of the defining things of it being a parallelogram that had equal sides. So like squares, their diagonals are equal. Rhombuses, their diagonals are equal. Diamonds, their diagonals are equal. So this is actually a true statement. Okay. The perimeter of a sector of a circle can never equal the circumference of the circle. So what this is talking about, and this is where I had a hard problem with this. So I'm going to draw a sector of a circle. It's saying that this plus this can never equal just the circumference. Honestly, I'm going to say false for that because I guarantee you if we were to sit here and mess around with that, we would eventually be able to find the sweet spot between the radii doubling, multiplying by pi, equaling the sector plus the two of them. So I'm going to say false for now because I don't know of a straight off the bat way to disprove that. Or way to prove that solidly. So I'm going to say false. Again, a lot of this uses the fact that it's their wording. So they said never. Now, had they said the perimeter of a sector of a circle can sometimes equal the circumference of the circle, I would have said true there because sometimes doesn't mean always. Now, if it said always, I would have to say false as well. Again, it's all about the wording here. Okay, if two angles inscribed in a circle are equal, the chords subtended by each are equal. Now, in a circle, here's where your wording comes in. It's in the same circle. So I'm going to say true for this because if it's in the same circle or in congruent circles, that is actually a very true statement. It is one of the statements we learn when we're talking about circles. So that is actually true. Okay. If two sides of a triangle are given, the limits between which the third side must lie are known. So if I tell you that this side is 2 and this side over here is 3. I do have limits. This angle right here cannot go above, for our purposes, let's just say 178, so that we would still end up with a 1 degree angle and a 1 degree angle. Okay, so I may be able to do 2 almost straight 3 and then make a little triangle, or I could be doing 2, 3, and here, okay? But I do have a limit on how big my third side can be. My third side has to be determined by the fact that I have a limit on how big or how small I can make that angle that is between them go. So I'm gonna say true for that one, because when I know the sides, I also know that my angle cannot be greater than a certain number or smaller than a certain number, because the constraints are that the interior angles have to equal 180 degrees. So the fact that I know the other two sides means I can deduce what that side length can be based off of knowing what my angle could be. Okay, tomorrow we're gonna finish off the true false section, so I'll see you then.